Hi everyone, welcome to Differential Calculus. Today we study lesson 4.3, basic curve sketching. Of course, we're gonna sketch a few curves. Example, for each of the following function, find a intervals of increase and decrease, the local minimum and maximum values, inflection point and interval of concavity, and sketch the function using the above information. Let's take a look at the first example. Fx equal x to the 3. We can do the first derivative. F prime x is 3x squared set equal to 0. And we have x equal to 0. So that's the critical point. And then from here, we'll do the testing. Let's get the interval here. 0. So we have a two interval, negative infinity to 0 and 0 to infinity. In order to know which intervals increasing or decreasing, we just got to pick a test point. I'm gonna pick a x equal negative 1 and f prime of negative 1. Well, that would be greater than 0. So it tells us that fx increasing. Pick x equal to 1. F prime of 1 is also greater than 0. So fx is also increasing. So fx increasing on these two intervals. You don't have to write out a solid number for f prime of 1. Right? You just have to know whether it is positive or negative. And that should be good enough because we are using the first derivative test. Function is increasing from negative infinity to 0 and 0 to infinity. It tells us that we have no local min max. No local min max value. Next step is we got to figure out the inflection point and interval of concavity. So to do the inflection point, take a look at the second derivative. And that would be the derivative of the first one, 3x squared. Set x, that's set equal to 0. So x equals to 0. From there, same thing, we cut this out into two intervals. One from infinity to 0, the other one from 0 to infinity. And pick a test point and do the testing. X equal negative 1. Here we use the second derivative test. So f prime prime negative 1 is the second derivative of set x. So do the substitution, get negative 6. That is less than 0. Tell us that fx concave down. And here, pick x equal 1. F prime prime 1 is positive. Tell us that fx concave up. So 0 is an inflection point. Might as well figure out exactly the coordinate here. F of 0 is 0 to the power 3, which is 0. So inflection point is that 0, 0. Using this information, yay, we can sketch the function. Let's sketch this sucker out. X, Y. Function is increasing and concave down from negative infinity to 0. So increasing and concave down look like this. Yeah, and then it hit this point right here. Then increasing and concave up. Yay, this is the graph. Beautiful. Let's get to the second example. B. We're gonna take a look at fx equal x over x plus 1, a rational function. F prime x is low d high minus high d low. X plus 1, low d high is 1, minus high d low is 1 over low square. So that tells us that we have x plus 1 minus x over x plus 1 square. So 1 over x plus 1 square. Well, 1 over x plus 1 square, x plus 1 square is positive. It's greater than 0. And then we know 1 is more than 0, so f prime x itself is positive, meaning that the function is increasing in its domain. Oh, we just got to figure out the domain here. Domain of a rational function is or a number in which the function is defined. Now you can see fx is not defined as x equal -1 because we cannot divide by 0. So domain is all the number except -1, -infinity to -1, -1 to infinity. Yay! We know it is increasing, but how does the function increase? So that is when we look at the second derivative. F prime prime x is the derivative of 1 over x plus 1 square. Well, you can write this one as the derivative of x plus 1 to the -2, and that will make life a little easier with the chain rule. So -2 over x plus 1 to the power 3. So we don't know what is going on to the left and to the right of x equal -1 because x equal -1 right here is a vertical asymptote. We're gonna cut the interval into 2 intervals on each side of the vertical asymptote. Infinity to -1, -1 to infinity. Pick a test point test. X equal -2. F prime prime x. Negative is positive, so greater than 0. Fx concave up. Put x equal to 0. F prime prime x. If you put 0, it's going to be negative less than 0. So fx concave down. That is it. We have all the information here to sketch this. Well, there's one more that we are missing. This is a rational function. So we need to look to see if it has the horizontal asymptote. horizontal asymptote HA. To do that one, we have to figure out limit x go to infinity fx, and that is limit x go to infinity x over x plus 1. Right? It's the same as taking the limit as x go to infinity of the leading term. Leading term on the top is the x, leading term on the bottom is the x. So that is 1 limit x go to negative infinity fx, limit x go to negative infinity x over x plus 1, and that is the same as taking the limit of the leading terms, because leading term go to infinity the fastest, x over x, which is also 1. What this means is y equal 1 is a horizontal asymptote. Yay, look at this, we have everything. Now let's sketch this out. Aren't you get excited for the sketch? X, Y. We have a horizontal asymptote at 1. We also have a vertical asymptote at -1. From negative infinity to -1, the function is increasing and concave up. So increasing and concave up look like this. From -1 to infinity, the function is increasing and concave down. It look like this. So there's the sketch of the rational function. Wow, amazing. Let's do one more. Something different. In C, we're going to take a look at the function fx equal ln x squared plus 9. F prime x is 1 over x squared plus 9 multiplied to the derivative of the inner function, which is 2x. So 2x over x squared plus 9. X squared plus 9 is always more than 0. So that means to find the critical number, we set the top equal to 0. F prime x equal to 0 is the same as setting 2x equal to 0. So x equal to 0. Okay, 0. Negative infinity to 0. 0 to infinity. Pick a test point, test it. Pick x equal to -1. Then f prime -1. Well, it's negative less than 0. Fx decreasing from negative infinity to 0. Now for the interval 0 to infinity, pit x equal 1. F prime 1, as you can see, it's more than 0. Fx increasing. Okay. The function go from decreasing to increasing, meaning that f of 0, which is ln of 0 squared plus 9, and that is ln 9, is a local minimum. And because this function only has one local minimum, it is also the absolute minimum. Okay, so now we go on to the second derivative. F prime prime x is the derivative of the first derivative, 2x over x squared plus 9. Let's use the quotient rule here. It's low d high, x squared plus 9 times 2 minus high, 2x d low times 2x over x squared plus 9 square. And we have a 2x squared plus 18 minus 4x squared over x squared plus 9 square. Now set this equal to 0. And what we have here is set the numerator equal to 0. So 18 minus 2x squared equal to 0. X squared is equal to 9. So x equal to plus or minus 3. Minus 3. 3. Negative infinity to negative 3. Minus 3 to 3. And 3 to infinity. We have 3 intervals to test. X equal to negative 4. F prime prime of negative 4. Well, if you look at the second derivative, that's going to be a negative less than 0. Fx concave down. Here, put x equal to 0. F prime prime of 0. Well, it's pretty clear. It's more than 0. So concave up. Put x equal 4. F prime prime of 4 is less than 0. So concave down. Yay! We have all the information here to do the sketch. If you want to sketch this one precisely, might as well figure out the exact inflection point. F of negative 3 is ln alpha negative 3 square. So that is 9 plus 9 ln 18. And f of 3 is also ln 18. Yay! Let's do it. Time for the sketch. Okay, so first thing is we're gonna locate the local minimum. 0 ln9 somewhere right here. L9, yeah, 0 L9 right there. And the next point is we're gonna locate the inflection point. Minus 3 ln 18. It's right here. 3 ln 18 is right here. We have 3 points. Now be very careful. Right? From negative infinity to negative 3, the function is concave down and it is decreasing and concave down. Okay. And then from negative 3 to 3, the function is concave up. So it will decrease unto 0 and it's going to increase. So concave up, we'll have a local minimum right there. Okay. And then from 3 to infinity, the function is increasing and concave down. Yay! Got it. Oh my God, this is a very nice sketch. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.